Hello, everyone. Thank you for joining me and the folks at Wintellect today. We're going to build something really fun with MongoDB. If you don't know who I am, I'm Michael Kennedy, host of the Talk Python to Me podcast and a number of other things. As you can see, let me just tell you really briefly about Wintellect, what those guys are up to, and then we'll dive into what we're going to cover today. So Wintellect has been doing training for over 14 years, all over the place, all kinds of training. They have some great on-demand stuff. They do custom software development. So if you need help with some really smart people, some of my good friends work here, and I really respect what they're doing. So you can have them come over and help you out. They've written a bunch of books. They do some other really good things with Microsoft around Xamarin and Azure and things like that. So FAQ right at the beginning so that we don't get a bunch of questions. One, can you ask questions? Yes, you can ask questions. I'll try to take a break every now and then, have a look and see, what questions are piling up. Is it going to be recorded? Yes, we're recording it right now. You'll be able to get it afterwards. Can you get the slides? Yes. Can you get the code? Yes. Everything you see me type here is going to be pushed into this GitHub repository, and you'll be able to get it not long after. Okay. Is there more stuff after? Of course there is. All right, so here is the GitHub repository, github.com/wintellect/webinars. So star, watch, fork this, depending on your level of interest. We'll have, at the bottom, there'll be 2018-02 Kennedy MongoDB folder or something like that with slides and everything. Okay, so let's get right into it. What are we going to cover today? Well, we're going to talk about some of the tools. You'll learn some really great tools that we can work with. We'll briefly cover what the benefits of choosing MongoDB over, say, a relational database are. We're going to build something really, really fun, something practical and real world and not a toy example. Now, that said, it's going to be a sort of a simplistic representation of it, but we're not just going to recreate yet another blog. We're going to create something fun, really relevant to the community, wrap it up with some concepts and questions and a few other things. So first of all, tooling. What tools are we going to use? Well, obviously MongoDB, right? If you're going to use MongoDB, that's obviously a required component to it. We're using the free open source version of MongoDB, not their enterprise server, but the community one. Almost everyone can be just fine with the community edition. There's a few things that if you're a large organization or whatever, you might need the pro edition, but community edition generally works. We're going to talk to MongoDB using an ORM, ODM technically, sort of a class mapping layer called Mongo Engine. And we're going to use two other fun tools. This little robot character up in the top right, this is the icon for something called, used to be called RoboMongo, now it's called Robo3T because the company 3T acquired the product. Anyway, it's by far the best way. And we're going to be using PyCharm. Okay, so real briefly, why is MongoDB interesting? Why might you choose it, say, over other similar databases, right? We'll have the debate about why it's a good choice over, say, a relational database. But there are other databases that are also trying to do the same thing that Mongo is. Cassandra, Couch, Raven, those kinds of things. If you compare MongoDB against the things that are similar to it, the databases that are similar, you'll find it's slightly different in terms of its use and its popularity. And this turns out to be really important, not because being popular is great, like as in high school, but it means there are many, many tools available for MongoDB, say, compared to RavenDB. It means there are many ways to access it, many libraries and so on. And also it's been seriously taken through the ringer, right? It's been used in some really intense environments. So for example, a common question is, can I use MongoDB if I'm doing like e-commerce? Yes, and one of the examples that they give is Under Armour ran their online e-commerce store on MongoDB, and they did $2 billion a year of sales through it. So whatever you're planning to do with e-commerce, chances are it's less than $2 billion, and it's already sort of, worked at that level. So chances are it's going to work for what you're doing as well. And that's where the popularity bit is important. The other thing is it's very wanted. So if you're looking for people to work with MongoDB, you're looking to hire people or get your good developers to work on it, it's almost twice as popular, or as wanted rather, than all the other databases. This is from the 2017 Stack Overflow Developer Survey, and it's definitely a compelling case. Okay, so that's why you might care about Mongo over, say, the other competing databases in the NoSQL space. Now, how do these things work? So if you're familiar with MongoDB, you've created these documents, you've modeled this way before, but maybe you haven't. So traditional databases, they have rows and they have columns, right? They're tabular, hence they're tables. But that's not how document databases work. So this is true for not just Mongo, it's also true for all the other document databases. They have stuff like this little green section here, where it's kind of effectively just straight data, right? We have an ID, we have a title, we have a duration. That's cool. But then notice this lecture section, right? This is actually sub-objects embedded within this document. So if I say, like, go to the database and say, find me with ID 1001, what I'll get back is this entire document. And in there are the lectures with their own details as well. And so you can think of the lecture part as kind of being a pre-computed join. So one of the really important but sort of black arts aspects of designing with these kinds of databases is to know when to model in this style, like lectures embedded within a chapter, versus two separate collections, what they're called in Mongo. They're not, because they're not tabular, but effectively two tables with a relationship between them, right? So when do you make that choice? That's one of the things we're going to talk about. But you can think of this as like a pre-computed join. And the quick rule of thumb here, before we get into too much detail, is just if most of the time you want the lectures when you get a chapter embedded, right? You're going to have only one database query, it'll be much faster, and so on. If you rarely want the lecture details when you get a chapter, then this is the wrong design, okay? So the $64,000 question, of course, is if you embed data like this, can you still ask interesting questions? So if you had a chapter table and a lecture table and some sort of foreign key relationship between them, you could easily query for lecture 10106. But when it's like this, and you have millions of records, can you still ask for lecture 10106? Deep down inside, like, so go to the chapter, go to the lectures list, go into the individual objects and look at the ID of those. Can you do that? And it turns out the answer is yes. And you can create indexes and all sorts of powerful stuff that make these types of queries work really, really well. And it's the fact that you can still do this in a clean and simple way that makes this type of modeling really powerful. Okay, let me see if there's any quick questions here. Yeah, so first question, Walter says, I don't see the MongoDB folder there yet. No, I have to do a pull request back into their repository. So I got to check this stuff into mine, into my fork of it, and I'll push it back. So Walter, it won't be there for a couple hours at least. Let's see. Try to say there's some cutting out of the audio. I apologize about that. Let me know if it keeps happening, okay? All right, so those are the questions so far. We'll keep going. All right, so you can do these nested queries, and that is what makes this type of modeling really, really powerful. All right, so what are we gonna build? Let's jump over here and look at it like this. Let's go to PyPI. There we go. Okay, so this place here is basically the package repository, the one and only for the Python space. If you do Node.js, this is like where the npm packages live. If you do .NET, this is like NuGet. okay? So you can see there's a ton of packages, 130,000 different packages. You see if we go down a little bit, here's some that are popular, some new releases, and so on. Here's one about kube control, makes deployment easy. Let's look at that. All right, so our goal for the rest of this webinar is to basically try to recreate the underlying data access layer and the database models that would let us render this page, okay? So let's take a quick note of what's on the page. So we have some basic information like the name of this, the name here. We have the version here, right, like so. When it was created, whether or not we're on the latest version, a little description here. This does not have so much. Let's put in a request like that. It's a popular package, a little more filled out. So down here we have a project description. We have some release history. This turns out to be really important. You can download the files, go to the home page. We have 3 maintainers. So it's going to be, we'll have this sort of one-to-many relationship, or many-to-many really, between users in our system and the packages for which they are maintainers. And we have other interesting things like what is the license, what languages does it apply to? And if we look at one of the ones that we're going to work with here, it's really hard, Engine. There we go. So if we go down here, you can see there's also these topics, like this applies to database, and it's a Python module, and maybe it's an ORM equivalent type of thing, and so on. So this is all interesting. And then what you'll notice if you click on release history is every one of these basically has a copy of things like, what is the build status right now, right? Apparently it was failing on that particular version. That's not great. But it might have a different about, it might have different maintainers, it has different dependencies based as it goes through its life cycle. So we're going to need to model the sort of release history of that, okay? So let's switch back over here. So with that in mind, how do we go about modeling this thing sort of conceptually in pictures, and then we're going to go and actually do that in code? Would propose as the relational model for this. I didn't actually go and look at the real database. I didn't take the code. I think this is open source. You can go get to it on GitHub, this project. So this is not actually the model. This is just me looking at that page that we talked about and saying, here is a reasonable relational model. So how does this work? Well, we have those topics, right? This is like, it's a package, it's a database tool, it's an ORM, and so on, right? So that maps over to the packages. We have the various programming languages it runs on. I didn't highlight it, but there's also what operating systems will this run on. So these are all related back to the package. Here's the build health, like is the CI passing, what's the code coverage level, and so on. Here are the maintainers, right? So we have users and we have packages, and then this is like a normalization table, linking some of the users to maintaining some of the packages in a many-to-many relationship. We have the package dependencies, which we might depend upon here. And then this is the one that actually has a ton of the data in it, this release history, because every time that comes out, like these details vary, right? And then what we didn't show on that page, but is also listed or tracked, is sort of every time you download a release, there's a record of what version of Python was it, what application, was it the pip installer, was it some other tool that did the download, and so on. So kind of an analytics system here. Okay, now I see there's a quick question. Let me look at that. So the question is, how much memory does the document database take for, say, the chapter example versus a relational database? And what is the speed of access? So let me just, I didn't make this point very strongly here. What you see here is not exactly what is stored in the database, okay? It doesn't technically store text. It stores what's called BSON, which is a binary version of JSON. So I didn't show you binary because we're people, we don't read binary, but technically it's not stored as text in the database, right? So in that regard, it doesn't take a lot more space for much of the stuff. However, one thing that is stored in the database is like this duration in seconds here. That is stored on every record, okay? That's not how that's done in a traditional relational database like SQL Server or SQLite or something, right? There's the schema definition that has duration in seconds, and there's just a place where the 1707 goes, right? So it does take a little bit more space, and you know, profiling, speed comparisons, all that kind of stuff are fraught with, you know, it's not my edge case that we're testing, so I don't believe it. But generally speaking, MongoDB will totally blow away a relational database in performance speed. Let me show you why. Let's bring it back to what we're just doing. So here is what we have to query to show the original page, right? We don't have to query the download history. I don't think we have to query all the release history, but we have to get the latest release history. And then everything else we have to do a query on. So it's 1, 2, 3, 4, 5, 6, 7, 8-way join, maybe 9-way join. That is a really slow way to get access to that page in a relational database. Let's look at how we model this in Mongo and see why it might be faster. Oh, here's how we model this in Mongo. So we have packages, which is actually a really light thing. We have release history, and the release history actually contains most of the data. The download entry we don't touch, and the users we'd query. So instead of doing a 8 to 9-way join, or like say an 8-way join plus a second query against the release history, we do 3 queries, right? Maybe potentially less even, right? So generally speaking, because the way you model the database, generally speaking, because the way you model the database, it's just going to be faster. But we'll get into that. Yeah, so I hear that the sound is cutting out for some of you guys. I really apologize about that. Those of you at Wintellect, if you hear that it's too much of a problem, ask me a question so I know, and then we'll do something. Okay, so here's how we model this in Mongo. But this actually, what happens here is a lot of that complexity, all those little arrows relating pieces of data, they're still here. But what happens in the document database is that we get those put somewhere else inside the document. So if we dig into this, it would look something more like this. Like over here in the ID, the packages. So over in packages, we have the ID of the package, we have the name of the package, and we have the maintainers, right? And these are object IDs are foreign keys, okay? So we don't need that maintainer package user normalization table. We just have them stored here. So getting to the maintainers is really quick and easy. It's one query over to here. And then to get the rest of the data, the release history, we just do, you know, the one that we're focused on, latest or something, if we're looking historically. And it has some flat data like package ID, version number. All the other tables that you saw, those are all now embedded inside of Mongo. So in this document. So our topics are embedded, our operating systems are embedded, our programming languages are embedded. Here's an embedded single document. These, you can see, this is a list here. And we even have our dependencies embedded with a little bit of detail there. Okay, so the modeling is a little bit more complex. The records are a little bit larger, but getting this information back turns out to be super, super simple and fast. All right, so that's what we're going to aim for, is something like this. So hopefully you guys are ready to write some code. That is enough theory. Let me put this over here, out of the way. So what we're going to do is, over in this folder, this is the folder you were talking about, Walter. We have some code. We also have some data. Here's a 50 megabyte data file that we're going to start out with some really simple basic code. But then what we're going to do is we're actually going to work with this much larger database that has hundreds of thousands of packages, because you really want to see this in terms of performance. Doug Farrell asks, is data duplication a problem? Like we have a list of operating systems represented in each release. It can be. It definitely can be, and it's a trade-off that you might make in these things. Is you could put those as a separate item and just embed, say, the IDs back to them, or you could copy them over there. It's a bit of a trade-off. I'll just leave it at that. You try to avoid it, but every now and then it definitely makes the most sense. So I'm going to start with this project we have right here, and I already have that open in PyCharm. We have a virtual environment with Mongo Engine and its underlying piece, PyMongo, installed. Okay. Now, it might look like there's a lot of stuff here, but it's not really set up yet. There's just some placeholders. So I wrote a little bit of code so we can stay focused on the actual programming against the database. So here we have this little input loop, and it's just going to go around and says, what do you want to do? I want to query packages, or I want to view like some analytics on the top downloads, or I just want to exit. And it just goes through and it looks at these functions here, and you can see it just says, okay, well, we got to go find the package and create the package and model them and so on. All right, similarly down here. So there's no real code written, but there is this little skeleton, which I'll go ahead and run for. So notice we're not talking to the database. So we could query the package. Whoops, how about we query the package, and it's package 1, 2, 3. Right, there's nothing coming back. So our job for this section is to go to do two things. Basically, go define a class that represents the package and the release history and the users and so on. And then go over here, and we have this thing I'm calling package service. It lets you ask questions, like do a query to find the package by name, right? That's not doing anything yet, but we're going to write it in a moment. All right, so the place to start to make all this work, of course, is to focus on the packages. All right, I see there's a quick question from Dragon. How do you relate packages to users? Let's hold that thought for just a minute. We'll come back to it when we do this here. All right, so the first thing we have to do is import Mongo Engine. Now, we could use what's called PyMongo, and PyMongo lets you map Python dictionaries into and out of MongoDB. That works fine, but you lose all aspects of integrity to what would be effectively a schema in your database, right? If you're just mapping arbitrary dictionaries of data in and out of the database, how are you sure that they're the same? How do you deal with like required fields and things like that? Like these are not concepts in Mongo, and so you got to put that structure somewhere. And so this layer Mongo Engine, which is like SQL Alchemy for you Python folks, or like Entity Framework for you .NET folks, this adds a lot of structure and actually makes the querying much easier. So we come over here and say this is a document. So there's two options for what we can put here. Well, more than two, but two that really matter. Document and embedded document. So everything that can be saved to a collection that can exist independently must be a document. Other things that must exist inside of other records, those are the embedded documents. All right. So we're going to create this package. It's going to be a document, and we don't have to give it the ID. I mean, we could say this is an object ID field, et cetera, but that already comes via inheritance from the document. So we have to give it a name, and this is going to be a Mongo Engine.string field. We can say required is true, right? This is not available as a feature in MongoDB, but it is in Mongo Engine. And we also probably want to get this back by name, so we can we'll have an index for that as well. Okay. Would relate users back. Let's go in to find the users real quick here. So again, same type of thing. Like that. And I guess we'll give them a name as well, right? call it username, whatever. Okay, we'll give them an email, which is going to be the same thing. We could come over here and say unique is true as well, so that'll create a nice uniqueness constraint there, and so on. So this document, this user, like I said, has implicit underscore ID, which is a MongoEngine.object ID field like this. Okay, every document in MongoDB does, and unless you take special actions, it's going to be what's called an object ID, which is like a UUID or a GUID or something like that. You could technically make it an integer or a string. Like we could make this, their email, be the primary key of this, but I'm just gonna let it go and generate that itself. Okay, so here's how we relate these back. So our maintainers is going to be a MongoEngine.list field. So it's going to contain a one-to-many relationship, many maintainers to this one package, effectively. And then in here, we're going to have a MongoEngine I think all we have to do is just put actually user in here like this. Got to import that character like so. All right. And then you guys are wondering, maybe just to answer your question, like, how do I get this back, right? You would go and do a query against the user collection saying where the user ID is in the maintainers list, effectively. Okay, so this is all well and good. Now, because I want to work with, let me come over here and connect to our local database. We have this database here, but let's go and show you how you create a brand new database, and then we'll go from there. So the one thing that we have to do in order to get started is we have to basically here, when you try to do queries or work with the database, here is where it goes. So we're going to come over here and say MongoEngine.register connection, and we have to set two things. We have to set the alias, and we have to set the name to the database name. All right. Now notice there's many other things we can pass: hosts, et cetera, and then that KWArgs means like arbitrarily many more things. So in a real deployment, maybe there's clusters with replication and sharding and all kinds of craziness. This gets way more complicated. But for this simple development version, it's pretty straightforward. Okay. So over in our program, one of the very, very first things we have to do is we want to go over here and say Mongo Setup. Is that what I called it? Yeah. Let's go up here. Whoops. Oh, it's in data.mongo setup. Like this. And then we'll say just global init, and let's call it PyPI2 for the moment. Okay. Now we have this other print header and stuff and so on, but let's just imagine we want to create a package and we want to save it. So I'll say P equals package like this. We'll use our service in general, but for now, let's just do this. And we'll just set the properties. Like the name is, let's suppose this is Mongo Engine. Like this. The maintainers will add onto their list of them. We'll just create some bunch of arbitrary IDs. Those don't actually link back to users because we haven't created them and so on, but that's fine. So I'll just do a print created package. Now, if you look carefully over here, that's a little small. If you look carefully over here, there is no PyPI2. There's no structure, nothing, right? But by virtue of running this code, it's going to create a package. Oh, we're not quite ready yet. It's going to freak out a little bit. We need to set some meta data here. And let me actually grab that from somewhere else that's more useful. I think I might have it right here. Should have opened this before. Sorry about that. Yeah, here we go. Let's see, this is package. Okay, so what we need to do is we need to set a little extra metadata. We'll come back to this stuff in a minute. So we are set what's the DB alias here. And so you saw me type that earlier. What does that mean? So you can, why do you give it any name like this? Like, in fact, you can create what's called a default one, but I'm not a fan of that style. So you can have more than one of these. This could be analytics. And this could be something like that. This could be on a separate server. It could be a separate database, whatever. So if you're, say, doing that download stuff, maybe you actually want to put that in a separate database because you might have gigs and gigs and gigs of data around analytics, and you might have, not very much at all. So what's an example of that? So like for my Talk Python podcast, over here, I have this, which has things like the episodes and guests and so on. But then over here, I actually have the downloads. And if you look at this one, where's the total? Here, the data size, like that divided by 1024 by 1024, that's 2.3 gigs of data, right? This data, if I lost it, it's not the end of the world. Whereas this data, this is what actually runs the website. It's only, what is that, 1 meg. 1 meg for the sort of operational data. And for the analytics, it's a gig. So there's really strong reasons to separate those because it's easy to back this up very frequently, this less so. Okay. Anyway, what we need to do when we define the class over here is say, this particular one goes to the collection called packages, lowercase p. If you don't put that, it'll just, that's the package name, the collection name. And this tells you basically which database or cluster it goes into, okay? We also do indexes and ordering and so on. Now I should be able to make this work when I run it. Has no maintainers. What have I done here? I think this might need to be a Mongo Engine. Oh, this needs to be an object ID. Sorry, like that. So I said that I was telling you that users went in there, but obviously I wasn't putting a user in there. There we go. Okay. Now if we go back, some interesting stuff has now happened in our database. We now have a second one, and we now have a record in here that has our name and our maintainers. That's what we created. And then we have this auto-generated underscore ID. Okay. So this is pretty cool. We put that in there and it's already working, right? It saw that the database didn't exist, so it created it. It saw the collection didn't exist, so it created it. And then it just inserted it. And you saw with my little mistake where it crashed, validate that for us as well, which is pretty cool. We don't need this.
Michael, are you still there? Uh-oh, folks, hold on. Michael, we're not hearing you.
Look at.
Now we can hear you.
This. Yeah, great. So this one has so much data. This is like, what is that? 500,000 downloads, 100,000 packages. It will take like 15 minutes to generate this database. So and the records have to match exactly. So give me just a second. And let's override a bunch of these. Okay, so now our packages is just slightly longer. We have our maintainers and our name. We're also doing something here where we're adding a created. One of the things I like to do in pretty much every database I work with is know when records got created. that's super helpful for users. It's helpful for like releases. It's helpful for downloads. Might as well put it on packages as well. And so we can even pass a default value here. So this is not the time now. This is the function now, which means anytime a record is inserted, it'll automatically set it to the the created time, basically. Okay, similarly, we can start out with 0 downloads and upgrade that. So let's quickly look through the others. So packages, you can see, has only 4 fields, 3 of which are really required. But this release history is actually, where it actually gets pretty interesting. Remember all those embedded things that we were talking about. So the topics are now in a list field of strings. The programming language, again, a list field of strings. Dependencies, in my drawing, this was more complicated. These could be like other objects, but for now, they're just strings. And then we have our health, which is this release health that's over here. And release health is an embedded document, so it lives within parent documents. And it has a CI level, a coverage level, and a health index, okay? So these are kind of like that status at the top of PyPI, showing us how healthy everything is. Okay, so let's go back to our program and tell it to not do this. Thanks a lot. And tell it to talk to the database that actually has all the records in it. Okay, I don't think anything interesting is going to happen. Let's just run it. No, nothing yet. So let's focus on some really, really simple things. Notice down here at the bottom, it wants to show you how many packages and releases and users and stuff there are. Let's go just look at these implementations, right? One of the patterns I really like is to put all the data access layer, put all the data access into its own layer and into one or more of these little package service, sort of download service type things. That means every time you do any database queries or whatnot, you just run one file or these one set of files that lives in this area. And that's more important in NoSQL databases than traditional databases, because it's up to the program to add some structure and validation more so than in, say, a true like SQL database with all of its foreign key constraints and schemas and whatnot. Okay, so we want to write this. So here's how we do it. If anyone's done anything with Django, it's real similar, slightly less similar, but still not that different than SQL Alchemy. So if we want to know how many packages there are, we go to package, we go to objects, and we say count. Right, so all the queries are based on this. If we wanted to know how many packages were there that just had, say, a particular name, we could say name equals 1, 2, 3, right? And this will basically say where the name is equal to 1, 2, 3. We could have created equals some date, right? That's cool, but usually you want to do greater than, less than operations. And so the way you do that here is MongoDB has all these sort of what are called dollar operators, like $GT or GTE for greater than or equal, and then you would set that to some value in its native query syntax. So these are sort of mirrored over here. You would say double underscore to apply an operator GTE. So where the created date is greater than or equal to this. Of course, we're not doing any of that. We just want to know how many there are, all right? And we'll do that for users, but this is going to be user. And we'll do that for release history, like so. And I guess download count as well. All right, so let's run it again. Sweet, look at that. We have 50,000 packages, 250,000 releases, 20,000 users, 50,000 downloads. Whew. Now, there's more data here than you would normally see, right? These releases are not just containing basically the record of what version it was and when, programming languages, all the dependency. This is like way more data embedded in there because of all that embedding we have right here in these 4 elements there, right? Lists of nested elements and so on. So that's a lot of data. Now let's clean this up a little bit and just go back to program. And let's start see if we can answer some questions here. Let's go to this query package. So we want to know what is the name. We're going to ask what the name is, and we're going to go find that. So the first thing we want to do is find the package equals package service. This doesn't exist, but we'll do something with name, pass along here. So we need to write this. Now it doesn't exist. Now, I give you a strong hint on how that works before. So what we'll do is we'll say package equals, and we go to the type here, package dot objects, and just name equals name, like that. And we need to return the package. Now, this is not quite done. That's going to be a query, which when executed will give us all of them. So we want just the first one. So that should work. Let's go and see if we can do something with this. Let's first verify the package sounds. Well, if not package, for those of you who don't do a lot of Python, you can just, this is a little bit like C++, you can basically test against whether this is none or null. And we'll say print no package with name found, something like that. Otherwise, we'll print found package.name created package.created.iso format, I think is what I want. All right, let's run it again. Let's do a query. Now, all the packages are just like this, like package 1, 2, 5, 7, right? I don't have the real package names, so we'll go with this. Ooh, we found it, look at that. And it was created beginning of the month, basically. And last time, 10 milliseconds. Let's find another package. Let's find package 9000. There we go. Created same time, right? Found a different ID and so on. So let's go over here and let's look at our packages. We already have our indexes. So notice I don't think we talked about that when I dropped it in. It's easy important in MongoDB and all the NoSQL databases, well, all the document databases, let's say, to really carefully think through your indexes. So we're using an index to find the name. So over here, I don't know why this is so verbose, there's a simpler way. Over here, we're basically running this query, what did I say, 9000 without the count, like so. Oh, packages. There we go. So we're getting this one back. You can see it has one maintainer. Some have many, some don't, and so on. But if you want to know, is it using that index, you can say explain, and if it says IX scan, then it's using an index. If it says something like table scan or some other thing, that's not good. So why does it matter if so much about these indexes? If we go back to our picture, which let me put that over here for you. Get rid of this. If you look over here, when you have a relational database, every foreign key, almost every foreign key maps to the primary key of another table. How many tables are there here? There are 10. So there's at least 10 indexes because the primary keys in this model. So just by virtue of designing the model, putting the stuff in there, make it impossible to save things and query them back, you have 10 indexes. Same thing happens in MongoDB, but we only have 4 tables. So there's only 4 natural or required indexes that appear. So we've lost over 50% of our indexes. And that means if you don't put them back, you will not be able to query nearly the right speed. So for example, notice this maintainers, we're actually creating an index on the items in this list. That totally works fine. It's no problem at all. Over here in this release history, we have an index on health.ci. So we're going inside of this into the release health that has a CI property, and we're putting an index on that. All right, so you got to really carefully think about the types of queries you're doing, because like I said, you lose like 50, 60% of your natural indexes, so you have to put them back. All right. Jawara asks, what is PyCharm? PyCharm is an IDE made by JetBrains. It's very similar to like Visual Studio, but for Python. So there's a free version, a community edition, which everything we're doing so far would work exactly the same in the free version, or there's a paid version which has some like web development features and stuff. Okay. Indexes, we're querying by name. Things are going well. Let's go ahead and write out a few more things. So we want to get the latest release now. So we're going to come over here to package service dot release latest package release. That's the one we want. Yes, I think we just want the latest one. We want to give it the package. So this one will let us do some interesting stuff. Let's go see how we might write that function. So if you pass in no package, it's not, we're going to bail. Otherwise, we want to go and get the releases. So we'll say release equals release history dot objects. And then over here in release history, let's go jump over there. It has a package ID, which is the foreign key relationship back. Now, this is a relationship in MongoDB, but it is not a, what I would call a strong, it's not like a foreign key relationship. So this one you kind of have to enforce in your own code, as opposed to say this dependency, this is an absolutely strong relationship of those dependencies to this release history, because they can't exist separately, right? So you have these two ways of relating fields. One is like embedding, which is like truly enforced strong relationships, whereas this one is kind of wimpier. I call it like a soft relationship or something like that. Okay, but what we're going to do is this is going to be equal to package.id, and that's going to give you all of them. But what we want to do is say order by, and for remember, right, you just put let's say created. Is that what we want? Version number. I'm going to go with created. And we want to do that descending, so we'll put a minus there. And then the last thing we want to do is say first. And then we'll just return release. Okay. So we'll go through, say, give me all the releases for this one, sort them in reverse, give me the first one. You could do last as well, I suppose, something like that. But this should work. And then let's just say, over here, we'll print this out. We'll say if not release, better check, because not in this database, I don't think every single package has a release. So we'll go ahead and check print, no release found, turn, and then we'll print release. Let's make a little F string. Version is the latest. Okay, let's run this one more time, see how we're doing. I'll create the packages, package 1, 2, 3. And we found that. Release 7.6.17 is the latest. Okay, super, super nice. All right, now there's a bunch of printing out of details here that is not worth you watching me do this. Let's go like, I think that. Oh, I copied too much, sorry. There. Okay, so we're going to print out the package name. We're going to print out information about its health, whether it's passing or failing continuous integration, its index and coverage, and so on. Now we're going to go and get the maintainers. This is going to answer the rest of your question, Dragon. And we're going to print their name and emails out. Then we're going to get the topics. Remember, that's sort of a foreign key relationship, but we embedded it. Same for programming languages, same for dependencies. All of those things would be joins. This would be like a join instead of a single query, and so on. Okay, so let's go write that little bit there. So this is pretty interesting. This is probably the most interesting query that we're going to write for now. come over here and we're going to go and say, well, I already have the package, and the package has a maintainers list, which is the IDs of the users. So I'll call them users here. We go to user.object, and all we have to say is underscore ID equals, I think it might be ID. No, I'm pretty sure it's underscore ID. We'll find out in a second. So we want to say this thing is contained within that set. So in SQL, we do an in-query. Turns out in MongoDB, how do you do it? With an in-query. So we say ID is in that. We just say give me all, and then we'll return a list of the users. All right, let's try to see if it's working here. Query package. Package 199. That doesn't sound amazing. Oh, objects plural. There we go. Sorry about that. Notice this is starting to run. Uh-oh, that's not good. This is starting to run. Yeah, I thought GoToMeeting was going wrong, but it just found some new hardware. Okay, so this is starting to run a bunch of times. So we'll say single instance only, because I haven't been closing it. You can see down here, there's a bunch. So let me kill a bunch of these off, and then it'll restart itself. Okay, so let's do our query. Package 123. Yeah, I guess it is just regular ID. Sorry about that. Query package 123. There we go. So check this out. We come over here and we do our query back for this package, and then we already have retrieved its continuous integration and project health. We just have to dig into the document to show it. We do a second query to get the release history, which contains everything else, okay? Contains the description for that release, the maintainers for that release, the topics, one, it could have been many. Here's the supported languages, the dependencies, all of that came in the release history, okay? And let's see, this was that inquiry, users.objects ID underscore double underscore in package.maintainers, right? How awesome is that? So Dragon, that's how you do this relationship that we were talking about there. Now, other final thing to look at is that's a lot of query. It feels like a lot of queries back to the database, right? And remember, we have tons of data, right? We have 250,000 releases, 50,000 packages. And like I said, the releases are richer than like a standard record would be. Still, that happens in 4 milliseconds, right? Super, super fast. Here, let me run it again. I'll query the package again. Package 9001, a little bit longer that time. Package 3500. Yeah, so somewhat variable, but still like not long, even though it maybe feels like we're getting a lot of data. And that's all we need to render everything on this page, right? I guess the one other thing is it maybe knowing whether or not we're logged in, right? Right, but everything you see on this page, we would have gotten in that one little series that we just did there. So we have just a moment left. Let me just write the other bit of code. We're almost done, and then I'll take some questions. So the other thing we have to do is do the view downloads. So let's go, and let me just copy this part in because it's not the data access part. So let's go and write the code for popular packages. All right, so what we're going to do is we're going to go in here and we're going to say, we're going to limit this to some number, get those, and we're going to sort them out. All right, and just show them. So this actually is super easy. So, and it's a little bit interesting why that's the case. So we'll say package.objects, all of them, don't need to filter them. But we're going to do an order by. On the packages, there's a, I think it's total downloads. So let's look. Dun, 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 dun. Total downloads, which is a long, okay? here's the total downloads. And then we want to limit it. This is like a skip page type of thing. And we'll just pass in the limit. Then we do an all. Then we'll return a list of packages or tops or something like that. Let's maybe flip this over in a way that makes more sense here. All right, so if we run this, it should do what we need. Let's go over here and just say view the downloads. Boom, look at that. So package 48960 had 43 downloads. Then the next one tied it for 43. Then you can see descending right there. All right. So very, very cool. Let's see. One more time. There you go. Once you run it once or twice, the connection opens up. Super, super fast to get that information back. All right. And that's because we put the index. Remember, this would be crazy, not fast, if it weren't for that right there. Okay, so that's it. I think we've written this page here, this sort of package description info pages, including all the release history and so on that we can go through here. And we've even added a little reporting about the most popular ones. So if you're up on the home page up here, we've got this. Okay, so any other questions? Yeah, so I'll give you just a second to throw those in there. If not, well, while you do that, I'll go and pull up the sort of summary information here for you all. All right, so we saw that we can have this complex model in relations, a relational database, or we have this much simpler model by leveraging the documents. Of course, we embed more stuff into them, and that's because almost every time we get a release history, we care about all the details that are embedded in it. All right, so let's review some of those concepts real quick. The biggest challenge with working with a document database is dealing with the different style of modeling. You don't have third normal form and all that simple stuff that's like, oh, well, these are the rules, you follow the rules, you're done. It's way more gray than that. So the main question you have to answer is, do you embed stuff or do you relate it? Is it like maintainers and users, or is it like dependencies and packages, right? So the 5-6 questions you want to go through here are, do you most of the time want the embedded data when you get the container? And the reverse is, how often do you want the embedded data without the container, right? If you get the container, do you also want the embedded data? And if you have the embedded data, do you still want the container? Those should drive your decision there. Also, the amount of data you can put into one record is set, and the larger it gets, the less good the performance is. So you don't want that to be a huge thing. Like you wouldn't put every download history into the package. That would be really bad. Okay. Let's see. So really quickly, create a connection like this. You got to register it. Here you say the alias and the database name. And then when you define these classes, you just put that in there as the meta piece. You define the columns or nested items by, say, Mongo Engine and the types. You can easily have these embedded fields here. So here we have an embedded document, which is a list of the embedded document list, which is the embedded bookings in this case. So here's kind of what we had with our lectures at the beginning. We do we do querying with objects, filters, and then modifiers, right? So we have objects. If you're just doing this one filter, you could put that email in the objects part. You can layer on the filters. So that's what filters for, like do an if test, throw another filter on there and so on. And then first we'll just give you the one, right? So that's really nice. You can get to sub-documents in your query like this. So bookings __ guest snake ID, that goes into the bookings collection and looks for entries which have a guest snake ID, which is contained within the owner.snake IDs. So really powerful way to compose these. All right, and that's it for my presentation. I see the questions. I'll come back to them in a second. However, I do have a free course on this if you would like to take it. It's at freemongodbcourse.com. It's similar but much more structured than this presentation, and it's totally different demo, so it might be worth checking out. All right, let me get to the questions. Can you show us the link to get the code again? Yes, I can show you the link to get the code again. Actually, let's just go up here. It will be right there. Okay. It's not there yet because I have to do a PR to that, and then they Winterlight has to approve it, but it should not be long. I'll go ahead and check in all that code right away and do a PR when I'm done. Would it be useful to use MongoDB with Solr text searching for like autocomplete with web apps? Yeah, I don't see why it wouldn't. If you're trying to use like data-driven autocomplete, sure, it seems like a great idea. I don't have any experience with Solr. There is full text search in Mongo, so that may help. But yeah, I'm sorry I don't know about Solr, but certainly it makes some sense to use it there. Does that make sense? Yeah. Another question about, so I think so, but I don't actually know Solr that well. So I don't really know Solr, so I'm gonna have to just leave it there. All right, any other questions? Yes, is the full text searching in Mongo relatively fast? It's indexed. I honestly don't know how fast it is. When I first tried it out, it was really new and wasn't working that well, so I stopped using it. And I would, on the records that need searched, I'll just put an entry that has every keyword and then put an index on that. And that's really fast. Like, for example, if I'm over in TalkPython, like that's this kind of stuff over here. Let's see, what am I looking for? Async IO, for example, right? Like that's fast, but it's not the full text search. Where do I think that MongoDB can use? Here's the best answer for that. Let's check this out. No, it is MongoDB.com. Let's go with that. Customers, success stories. So what I would do is I would come over here to who-uses-MongoDB and look through here. You have companies like Royal Bank of Scotland, which is using MongoDB as the core basis of their trading engine. You have Facebook, you have Expedia using it for their travel. You have EA for millions of online players. If you have a use case in mind, see if someone else is using it over here, and there's probably even a write-up, okay? I would say it could be used for like 90% of what you need to do. All right, so another question related to Solr, sorry. What is the editor that I use? The editor I use is PyCharm, which is here. There's a pro and a community free edition. Definitely think it's the best one out there. I also like Visual Studio Code with the Python plugin. I also like proper Visual Studio from on Windows. They have a pretty decent Python tools for Visual Studio, but still none of them are as good as this. How does MongoDB scale out compared to something like Oracle? They scale up to a limit, but they don't scale out well. MongoDB scales out insanely well. They have built-in sharding, so I could change my connection string and connect to a like 20 server cluster that shards the data and parallelizes the queries, and I don't have to change my code at all, right? So they have really great replication and sharding for horizontal scale, way better than a lot of relational databases. I guess I'm thinking about DB sharding. Yeah, so yeah, that's pretty straightforward. Why don't I use PyMongo? There's a couple of reasons I'm not using PyMongo. I touched on it a little bit, but if you write code like this, it takes care of so much of the integrity that is lacking in PyMongo. In PyMongo, I cannot set a default value. So I could forget to set it, right? I could compute it wrong. I could set it to date instead of date time on accident and screw stuff up. I cannot say there's a name that is required. The type even the type that it's a date time versus a string versus a list cannot be set or enforced in PyMongo. It's literally, I do this. Right? Is that correct? I don't know. You tell me. Right? There's no enforcement. So these are the things I read and write to the database. I cannot put like little helper functions on here either, right? Like I could define other methods, right? If I wanted, and so on. And you don't have required fields. You don't have it automatically doing the indexes. So, I mean, there's a big debate to be had between ORM, ODMs, and straight query language. I feel that the structure and enforcement that is lacking in MongoDB is brought back in Mongo Engine or some of these other ORMs, ODMs. So I think it really adds a lot of value. If you don't like it, so we totally could have written this with PyMongo if you didn't mind writing in just dictionaries. So that would be fine. All right, that's it for the questions. Unless you all have more, feel free to throw them in. All right, how about this for the grand finale? Push them up there. All right. So those will be all. I'll go do a PR against that in just a second, and whenever Winterlight gets it online, it will be available for you. Let's see. Chetnya says we don't have joins in MongoDB. I think they may have added something that within a single document you can have a join, but you're right. No, they don't. They also don't have cross-document transactions, but they actually announced that for a new features coming in the summer. So they will have the ACID properties and transactional behavior coming in Mongo 4, but no, it's not there either. Doug, thank you for coming. I recognize your name from other interactions, so thanks for being here. Yeah, Scott, you're welcome. Thanks everyone for coming. Just checked all that stuff in, so get it online as quick as possible. Thanks again. Yep, you're welcome, everyone. Thanks. Goodbye.